Have you ever stopped to think about how messaging apps like Signal keep your conversation so ridiculously private? Well, the secret sauce is this absolutely brilliant piece of crypto called the Double Ratchet algorithm. And today, we're going to tear it down and see exactly what makes it tick.
All right, let's just jump right in with a pretty terrifying question. Imagine every single message you've ever sent. All your private chats are locked up with just one single master key. Now, what happens if a hacker gets their hands on that one key?
Yeah, it's a total disaster. Just like that, with that one key, an attacker can read everything you've ever sent in the past, and everything you're going to send in the future. Your entire digital life, past and future, is wide open. This is exactly the kind of catastrophic failure that modern cryptography is designed to prevent.
So this is what we call the one-key problem, and it's why old-school encryption just doesn't cut it for messaging anymore. We need something that's, constantly changing the locks on the door. And the name for that clever mechanism is a ratchet.
Think about a real physical ratchet, like on a wrench. You know the one. It clicks forward to tighten a bolt, but it absolutely cannot go in reverse. Well, in crypto, it's the exact same idea. We create new keys from old ones, but it is strictly a one-way street. You can never, ever use a new key to figure out what an old key was. And that right there is the fundamental concept.
Now, the double ratchet, and the name kind of gives it away, has two of these things working together. So let's start with the first one, which is called the symmetric key ratchet. It's symmetric because both you and your friend use the same key for each message, and its job is to secure every single message that goes back and forth. To really get this, you got to understand the key hierarchy. The best way to picture it is like a tree. You start with one big, strong root key, that's the trunk. Then that trunk sprouts a few main branches. Those are your chain keys. And finally, from those branches, you get all the leaves. And those are the message keys, the things that actually encrypt and decrypt your individual messages.
So how does this work every time you hit send? Well, for every single message, the system grabs the current chain key, one of our tree branches, and it does two things with it. First, it derives the unique message key, a leaf, to encrypt that specific message. Second, it uses that same branch to grow the next chain key in the sequence. Then, and this is the most important part, it destroys the old chain key. It's gone forever. The chain just keeps moving forward, one message at a time. And this constant forward motion gives us an absolutely critical security feature called forward secrecy. Because those old keys are always being deleted, even if an attacker manages to steal the key you're using right now, they can't go backward. They can't read your past messages. Your history is safe, locked away for good.
Okay, but that's all about protecting the past. What if an attacker compromises your phone right now and steals all of your current keys? Well, that's where the second ratchet comes in. You can think of this one as the healing key. It kicks off a process that builds a whole new layer of security from the ground up.
Now, this second ratchet doesn't run for every single message. Instead, think of it like a periodic, system-wide reset. It uses a really clever cryptographic trick called Diffie-Hellman, which lets two people create a brand new shared secret, even if someone is listening in.
So here's what goes down. Every once in a while, your phone just automatically creates a new key pair and tucks the public part into a message you're sending. The other person's phone gets it, does some math, and computes a new shared secret. This brand new secret then gets mixed into the main root key, the trunk of our tree, to create a completely fresh one. And from that new trunk, all new branches, or chain keys, are grown.
And this is what gives the algorithm its superpower, something called post-compromise security. I like to call it self-healing. It means that even if a hacker completely compromises your device and steals everything, all your current keys, the very next time this DH ratchet clicks forward, it generates a brand new root key that the attacker knows absolutely nothing about. Just like that, the system automatically heals and locks the attacker out. This is an unbelievably powerful guarantee.
So, we have one ratchet that moves with every message to protect the past, and a second, more powerful one that periodically heals the whole system to protect the future. So let's see how these two machines work together to create, well, a fortress.
This table really breaks down the division of labor perfectly. You've got the symmetric ratchet acting as the day-to-day workhorse, right? Clicking along with every message, giving you that crucial forward secrecy. And then you have the Diffie-Hellman ratchet, which is like the master reset switch, providing that incredible post-compromise security that can heal the entire conversation.
And that's it. That's why it's called the double ratchet. It's not one, but two independent mechanisms, constantly clicking forward, working in harmony to protect you from every possible angle. What you end up with is a system that's in a state of constant evolution. The keys are never static. They are always being updated, replaced, and most importantly, destroyed. It's like a living security system. It's even smart enough to handle real-world network hiccups, like when messages show up out of order.
Okay, so why is this such a big deal? Why am I so excited about this? Because honestly, this design is a revolutionary leap forward for how we think about private communication.
To really see why, let's just quickly compare it to the encryption that protects most of the web, called TLS. With TLS, you basically get one master session key for your whole conversation, which is fine if you're just buying something online, a short interaction. But if that key ever gets stolen, the whole session is blown wide open. The Double Ratchet is different. It's built for long-running conversations, so it uses a new key for every single message. A compromise is just a tiny blip that gets healed almost instantly.
So what does this all add up to? You get these incredible revolutionary guarantees. Forward secrecy means your past is always safe. Post-compromise security means your future is always safe because the system literally heals itself. These two things together provide a level of security and resilience that people just dreamed about with older systems.
And I think this quote just sums it all up perfectly. TLS was built to protect web transactions, commerce. The Double Ratchet was built to protect something way more intimate and important: ongoing, private, human conversation. It really creates a safe space for us to talk, which kind of makes you wonder, where else do we need this kind of powerful, self-healing security?